जेरे आ वञे त जब स्क्रीन ते वो ॾसाए त जेरे आवे कितने नंबर ऑफ पीपल इन वो भी ॾसाए. अस्सलाम वालेकुम फरूक भाई. अल्लाह का फजल है. जल्दी जल्दी बात कर लें, मेरा सेशन स्टार्ट है. 7 बजे के बाद. सही है. 7 बजे सेशन ख़त्म होगा. बड़ी मेहरबानी सर. उसामा बिन अरशद says अस्सलाम वालेकुम sir. वालेकुम अस्सलाम व रहमतुल्लाहि व बरकातुहू dear. And also you can, if anyone can. Nasir Muhammad says assalamu alaikum wa alaikum assalam wa rahmatullahi wa barakatuh. If anyone can confirm my sound is fine, and thank you for the likes. How many viewers are there? Okay. So Osama bin Arshad says perfect. Okay. So let's. Mir says hi dear. Thank you for joining my live session. Really appreciate that. Okay. Okay, let's. Shri Krishna Lubal says 10. Okay, dear. I was asking from my team actually, but thank you for confirming. So let's start. Today we'll do fractions, and this is we'll have 5 sessions of fractions where we'll discuss everything about fractions. So this is part 1 of fractions live sessions. So there will be a series of 5 live sessions for fractions, and this is the first one, part 1 of that. So what is halves and quarters? Let me bring a picture here. Let's. Okay, so we call it ice cream, but in every uh, country this has a different name. So what do you people call this one? So here we have this ice cream. Now this same ice cream now here is cut in half by a black line. Let me do it again. So this is another picture of the same ice cream. What's happening here? Okay. So this is the same ice cream, but this line, black line, has divided this black line. Let me change the color to green. This black line has divided the ice cream in 2 equal parts, and each part we call 1/2 or 1/2, like that. And we can write half like this also, 1/2, and we can write 1/2 like this also. These both are 1/2s. And another thing I wanted to tell you is that 1/2 plus another 1/2 is 1 whole, or just 1 we call it. Okay, and this is 1/2 and this is 1/2. So it's a very simple concept, but I wanted to go from very uh, beginning. Just start, and let's delete this and bring another picture. Now here we have a rectangle, and this rectangle is cut in half here, and half of the rectangle is shaded here. It's same rectangle, but here it's half of the rectangle is shaded. So this is one half and this is another half, and exactly same rectangle is cut in half, or you can say uh, half of the rectangle is shaded in different way. Exactly same rectangle, but here it is shaded in a different way, and it's the same concept. Now let me show you the same rectangle, but instead of instead of doing getting two parts, we can divide that in four equal parts like this. So let me show you, and so here that same rectangle is now divided into four equal pieces, and each piece is called quarter or 1/4, 1/4, like this. And let me tell you, four quarters, they add up to one whole, because if we shade all of them, this is 1/4, 1/4, another quarter, third quarter, and four quarters. So four quarters, they add up to the whole one. Now all of the rectangle is shaded here. Okay, so this was a simple concept, and let's check. Let's delete this, and let me show you another concept that I want you to see. Here 1/4 out of 4 quarter is shaded, and in this next diagram, here, same rectangle, 3 quarters are shaded. So how do we, here 1/4 is shaded, and here this 1/4, another quarter, and another quarter, 3 quarters. So this is 1/4 that is shaded. Here 3 quarters are shaded. And now if we take this part, and this part, just a minute, If we take this part and bring it here, we have full whole. So this means what? This means 1/4 plus 3/4 is 1 whole or 4/4. Also, as I told you before, if it is 1/2, it can be written as 1/2 like this also. Exactly same, 1/4 can be written as 1/4 like this, and 3/4 can be written as 3/4 like that. So you should know how to uh, write fractions like this. Okay, so let me delete this part, and here is another example of 3/4. Here also 3/4 are shaded. So this is 1/4, another quarter, and this is 1/4. So 3/4 are shaded. Now, and 1/4 is not shaded. Let me write 1/4 here. So just notice here, if a shape is divided in equal parts, only then you can say 1/4 is shaded, 2/4 is shaded. If the lines, they are not dividing them in equal parts, then you cannot say that. So let's do an exercise. Vicky Donor says, hello sir. Hello Vicky Donor, thank you for joining my live session, appreciate that. So let's do these questions. You can do it them yourself, and I'll do it here, and hope if you get the answer before me, you can write it in the chat box and I will respond to that. Mir says, fraction topic. Exactly, Mir. This is part 1 of fractions. We'll do total 5 parts. In the coming week, the remaining 4 parts will be there, and tomorrow it will be present master class of percentages. So what part of each of these shapes is colored? All answers are 1/2. Be careful here. 1/2, 1/4, or 1/4 you can say, or 3/4. So here clearly we can see only 1/4 is shaded. So answer to this is 1/4. Here we have 1/4, another quarter, and another quarter. 3/4 are shaded, so 3/4. Here we have 1/2 shaded and 1/2 not shaded. So the answer to this question is 1/2. Here also 1/2 is shaded, so 1/2 is the answer. And here it says, what is the missing fraction? So 1/4 plus what is 1? This one is 4/4. You remember, it's same as 4/4. So already 1/4 we have, the remaining is 3/4. So 3/4 is our answer. And Hitaksha Putran says 3/4. Thank you, dear, for confirming. Okay, let's move on to the next one. How do we write fractions? Here we have this diagram. Now tell me how many boxes there are, how many squares total. and in this how many squares are shaded. So to write this in fraction form, we can see clearly that there is 1, 2, 3, 4, 5, 6, 7, 8 squares, right? And 2 of those 8 are shaded. So we write 2 over 8 like that. So this is 2/8. We say it like 2/8. The number on the numerator, upper number, this is how many squares are shaded, and the number on the bottom or numerator is total number of squares, right? That's the idea here. Let's do one more to just clear the concept. Here in this diagram, how many triangles are there? We can see 1, 2, 3, 4, 5 triangles total, but shaded are 1, 2, 3 triangles. And be careful, every triangle has the same shape, same area, everything same. So we can say 3 are shaded, and how many total? 1, 2, 3, 4, 5 are 5 triangles. So 3 out of 5 triangles are shaded. And the simplest way to, if we do the reverse of this concept, if we have the fraction and we have to make a shape, then the simplest form is, let's say we have this fraction 1/7. The simplest way of making a shape that has, or let's make it 2/7. I have this diagram here that says 2/7. So now here we have sevens. We have 7 squares, 1, 2, 3, 4, 5, 6, 7, and in this case 2 of them are shaded. So total boxes are, or total squares are 7, and 2 out of those are shaded. So the fraction 2/7 can be presented by this diagram, and this diagram says 2/7. Okay, so let's do some exercise now. The question says write the fraction shaded for each of the shapes below, and you can write the answer in chat box and I'll do it here. So this is the simple concept of fractions. No rocket science, nothing fancy, but this is the base of what we are going to do in coming sessions. Okay, here how many boxes are there? Total 1, 2, 3, 4, 5, and only 2, this box and this box, 2 of them are shaded, so answer will be 2/5. And here we have 1/2 shaded, 1/2 not shaded, so the answer is 1/2. It's saying fraction that is shaded. Now here 3 triangles, same shape, everything same, so 1 out of 3 is shaded. and here we have 1, 2, 3 shaded. Out of how many? These are 3, 4, 5, 6, 7, 8. So 3 out of 8 is shaded. And here we can see 1/4 is shaded, and total are 2, 3, 4 triangles here, or this square is divided into 4 equal sections. Here we have 1, 2, 3, 4, 5, 6 total triangles, and 3 of them are shaded. So that's our answer. Let's move on to the next one, right? Now we should understand a concept. I have told you before also in this same session that when we divide, let's say, one square into two equal parts, right? Two equal parts. Let's do like this. Two equal parts. This is half and this is half. 1/2 and 1/2. And 1/2 plus 1/2, we say it is total whole one, but we can say it's 2 halves, right? And 2 halves is 1. Exactly same concept. 2 halves is also is 1. 3/3 is also 1 whole, and 4/4 is also 1 whole number, and 5/5 is also whole 1. Okay, now how can this knowledge benefit us? If we have to, let's say, we have 1/4 and we need to know, to make it whole, how many quarters we have to add. We know that 1/4 is there. Let me change the color. 1/4 is there already, so we need 3 more quarters to make it whole 1. And if we have 2/5 and we want to make it whole 1, we know that already we have 2/5 and we need 3 more fifths, because 2 plus 3 is 5, to get whole 1. So that's the concept, and this concept can make adding and subtracting fractions that has the same denominator very easy. We can just add or subtract the numerators, and that's our answer. So this is the simplest concept in fractions, and let's do some exercises there. Mir says 3/6. Exactly, the answer to that question was 3/6. So here, what is the next entry in this series? 1 is equal to 2 halves, then 1 is equal to 3/3, then 1 is equal to 4/4, then 1 is equal to 5/5, and what is the next one? Okay, actually this is supposed to be here someone. Okay, here somewhere. So what is the next entry like this in this series? Anyone can tell me? So the next series will be 1 is equal to 6/6, right? Now the question is here, what is the missing fraction? We have already 1/2. We need another 1/2 to get whole 1. Here we have 2/5, so we need 3/5. And the easier way is just subtract this 2 from 5. 5 minus this 2 is 3. So we can write that here, and the denominator will remain same. Here we have already 1/3, so we need 2/3, because this 2 plus 1 is 3 total. To make it 3/3, we need 2/3. Here it's 5/6. We to make it whole one, we need 6/6, right? Here. So 5 already we have. We need one more, 1/6, to make it one whole number. And in the next concept or exercise, you will know how this can how we can get advantage of this knowledge. We have here 3/8. What should I add to this 3/8 to get whole one? Whole one is 8/8, right? So already 3/8 we have. We need 5 more to get 8/8. That is whole one. Here we have 7/10. 10 minus 7 is 3. We need 3/10 more to get whole one. This is very simple, and I don't want to spend a lot of time on this. We are going very slow. So if you don't understand anything or some concept is not clear, you can right away write your question in the chat box, and I will respond. So we already have 1/7. We need 6 more 7s. 6 7s to get whole one, that is 7/7. Here we have 3 11s, and we need 11 11s to make whole one. So 8 more. 8 11s we need more. Here we have 13 20ths. So 7 more we need to make it 20 20ths. That is whole one. And 99 hundredths, we need one more hundredths, 100ths, and then we have 100 hundredths, that is whole one. Okay. So let's move on to the next concept. It's adding fractions. And in today's lesson, we'll do adding fractions and subtracting fractions that has same denominators or same bottom number. Let's say we have 7/10 plus 2. Thank you for the likes. Thank you, dear. 2/10. So 7/10 plus 2/10, we have 9/10. We just add the numerators, and we have 9/10. Same here, but sometimes we have to take care of the whole ones also. Let's say we have 7/10 and we add 6/10 to it, and we know 7 plus 6 is 13. But in this 13, be careful here, in this 13/10, we know there are 10/10 and 3/10, right? 10/10 and 3/10, and we already know that this 10/10 is one whole. This 10/10 is one whole number. So we'll put 1 here and then 3/10. One whole number 3/10 is same as 1 plus 3/10. Mind you, we should not, my English is not very good, so I didn't want to say mind you. Just be careful here. One whole number 3/10 or 1 plus 3/10, it's the same thing. And this is called top heavy fraction, where the numerator is greater. So we have to convert this into this mixed number, right? When we have, okay, let's do one more. We have 4 7s plus 6 7s plus 8 7s, right? So 4 plus 6 is 10, and 10 plus this 8 is 18. We have 18 7s. But we know that in 18 7s, we have 7 7s, then another 7 7s. So this is 14 7s, and the remaining 4 7s, right? And all of these are, this is one, this is another one. So actually we have two whole numbers, and then we have 4/7. So we can just for clearing the concept, we are doing it each and everything separately. Other than that, you can just right away divide 18 by 7 to get two whole number 4/7. But in this case, just to hit the idea home and making this knowledge part of our body, we need to see this. Okay, so let's do some exercise. So try to add them, and if you get the answer, you can right away give the answers, and I will do it here. So 1 7 plus 3 7s is 4 7s. We just add the numerator. Then 2 9s plus 5 9s is 7 9s here. Okay, 2 6 plus 5 6 is 7 6. But here I can see the numerator is greater, and in 7 6 we have 6 6 plus 1 6, right? And we know that this 6 6 is 1 actually. So we can say 1 whole number 1 6. Here we have 3 8ths plus 1 8ths plus 3 8ths. So 3 plus 1 is 4, 4 plus 3 is 7. So we have 7 8ths. Better. Okay. So here we have 7 11ths plus 10 11ths. So 17 11ths. And in 17 11ths, we know that we have 11 11ths plus 6 11ths. That is, this is 1. This is 1. So we have 1 whole number 6 over 11 or 6 11ths. Alright. Okay, here 17 20ths plus 6 20ths is 23 20ths, and in 23 20ths we know there is 20 20ths, that is equal to 1, and 3 20ths remaining. So this is same as this is 1. So we write 1 here, and we are left with 3 20ths here. So 1 whole number 320 or 3 20ths is our answer. Today nobody is writing answers or chatting. I request you or encourage you to write your answers, and then it will be a little interactive session. Okay, so the last one, 2/3 plus 8/3 is, we just add the numerators. 2 plus 8 is 10. We have 10/3. But in 10/3 we know that there is 1/3. So 3/3, then another 3/3, then another 3/3, then we are left with 1/3. So total is, this total is 10. So we know that this is 1, this is 1, and this is also 1. So we have 3 whole numbers and then 1/3. So that's our answer, 3 whole number 1 over 3. Okay, let's do the same thing but with subtraction, where the denominator is same. Let's say we have 7 ninths minus 2 ninths. Like the addition, we just do the subtraction here in the numerators. So 7 minus 2 is 5. We have 5 ninths. If we have, let's say we involve whole numbers also, 3 whole number 3 over 5 minus 1 whole number 2 over 5. If we have like this, so deal with the whole numbers separately and with the fractions separately. 3 minus 1 is 2. So we have 2 whole numbers, and because the denominators is same here, we can just subtract 3 minus 2, that is 1. 1/5. We have 3/5 minus 2/5, so 1/5 is our answer. But sometimes what we have is something like this: 5 minus 1 whole number, 1 over 3 or 1/3. So what we do here is, be careful here, we have to subtract this one as well as this 1/3 also. So here we have 5 minus 1, that is 4, but we still have to subtract this 1/3. And remember, when we have 1/3, this 1/3 has to be subtracted from 1 out of this 4. So this 4 I can write as 3 plus 1, right? And then we have to subtract this 1/3. But whenever we subtract any fraction from 1, we just write 3 as we did before. 3 minus this 1 is 2. And we have the same denominator. And this 4 will become 3 because this 1/3 has been subtracted from 1. Or if I go a little deep, we have 4 minus 1/3, and this 4 can be written as 3 plus 1 minus 1/3, and we are subtracting 1/3. This is, we already have 1 means 3/3. So now we are clear that we already did this a lot of times in today's sessions. So 3/3 minus 1/3 is 2/3. So we already have this 3 plus 2/3, that is 3 whole number, 2 over 3 or 2/3. So be careful here. A lot of people understand like this directly. Sometimes some people need explanation like this, but for most of the people this explanation becomes confusing. So stick to it that we have subtracted already. Let me change the color here. We already subtracted here. 5 minus 1 is 4. So we have 4 here. We still have to subtract 1/3, and 1/3 will be subtracted from this 4, and it will be 2/3, and 4 will become 3. Okay. So let's do some exercises here. Or I have one more question, another example of this same thing. So we have 3 and 1/5 minus 1 whole number, 4/5. Here we have 3 minus 1, that is 2. But here when we do 1 minus 4, it's still we have to subtract 3/5 here. So 1 minus 4 is minus 3. So minus 3 over 5 it is. We have to subtract this 3/5 still. So this 2 will become 1, and this 3/5 when we subtract it from 1, that will become 2/5. Or you can say 1 minus 3/5 is same as, this is 5/5, right? 5/5 minus 3/5, and we have done this many times today. This will become, this is 5, sorry. Let's write this 5 again. This is 2/5. So that will be our answer. Let's do some exercises and we call it a day. Okay. So 6/7 minus 1/7, it's simple. 6 minus 1 is 5. So 5/7 is our answer. Here 8/11 minus 3/11. 8 minus 3 is 5. So we are left with 5/11. Here we have 5 minus 2, that is 3. So we write 3 here. And then we have 4/5 minus 2/5. So 4 minus 2 is 2. We are left with 2/5. That's our final answer. And here also 7 minus 3 is 4, and here 5 eighths minus 2 eighths is 5 minus 2 is 3, 3 eighths. We are left with 3 eighths. Now a little variation is coming. Here 6 minus 3 is 3, and we have to subtract this 1/3. So this 3 will become 2, and this 1/3 we have taken 1 away from this 3, and that one we have to subtract this 1/3 from. So when we subtract 1/3 from that one, it becomes 2/3. Just that. And the quickest way is just decrease 1 from this number, this whole number, and then denominator will remain same here. Just do this minus this. So 3 minus 1 is 2, and this is our answer. Here also we just decrease 1 from here. 4 will become 3, and then in the denominator this will remain same, and numerator will be 4 minus this 3, that is 1. So 1/4. And the concept here is we have to split this 4 into 3 and 1, and that 1 will take care of this 3/4 to get negative 3/4 to get 1/4. Here we have 4 minus 1, that is 3, and here we have 1/6 minus 2/6, so minus 1/6 still we have. And as I told you, just decrease 1 here, it will become 2, and 6 minus 1 is 5, that will be the numerator, and denominator will remain same. 2 whole number 5/6 or 2 whole 5/6 will be our answer. Now here 8 minus 6 is 2, then 2/5 minus 3/5 is 1/5, negative 1/5, and we have the same type now. This 2 will become 1, we decrease this 1 by 1, and denominator remains same. 5 minus 1 is 4, numerator will become 4. So 1 whole number 4/5 is our answer. Okay, dear all, this is it for today's session. And if we do these live sessions daily from Monday to Friday at GST time, that is Dubai time 6 p.m. and UTC or EST time, that is 10 a.m. and GMT time 2 p.m. But on Saturdays there is master class, like tomorrow it will be a master class of percentages, that is at GST time, Dubai time 8 p.m. and UTC and EST time 12 noon, and GMT time will be 4 p.m. And if you want to know more about our online courses, all these concepts that I am teaching here in live sessions, these and a lot of others, like our green math course, it has around 400 small lessons with 400 practice sheets covering all the math topics from grade 3 to grade 10. And there are other courses also. If you want to know more about them, go to www.guinnessandmathguy.com. I have put it in the chat box. You can go there and you can see our courses. So thank you for joining my live session. I appreciate that. See you tomorrow at 8 p.m. Dubai time. Stay blessed, stay safe. Assalamu alaikum wa rahmatullah.